In 1.7, we're going to continue with the algebraic strategies for evaluating limits. In the last section, we did factoring, and then we did a special trig limit. Okay, remember we only have to do the special strategies if we get an indeterminate limit. So if I go ahead and look at this one right here, if I plug in x is 5, 5 plus 4 is 9, square root of 9 is 3 minus 3, which is 0. And then 5 minus 5 is 0. So I'm going to get 0 over 0, which is indeterminate, which means there is a limit. I just don't know what it is yet, so I do need to do some algebraic manipulation. So this strategy is I'm going to rationalize fractions with the radicals. So I'm going to go ahead and look at this. I see this, the radical part is in the numerator. I'm going to multiply by the conjugate. After we multiply it, you'll see why it's useful to do so. But let me do it first. And then when we look at it, then we look at our result, it will make sense. Okay, so this is the square root of x plus 4 minus 3. The conjugate is the square root of x plus 4 plus 3. If I do it to the numerator, I'm going to do it to the denominator. Okay, and the reason we like multiplying by the conjugate is because it creates like a difference of squares. So if I do the square root of x plus 4 minus 3 times the square root of x plus 4 plus 3, that's it multiplying. I'm just going to make a difference of squares. So the square root of x plus 4 times the square root of x plus 4 is x plus 4. If I were to do FOIL, the middle term would distribute it out. And if I do minus 3 times positive 3, I get minus 9 at the end. Now for the denominator, I'm actually not going to multiply it out because it's not going to come out nicely. So I'm going to keep the x minus 5 in parentheses, and next to it, I'm not going to lose the conjugate, which was the root x plus 4 plus 3. Now the numerator is going to simplify a little bit. X plus 4 minus 9 is x minus 5. Okay, let me rewrite the denominator. Which I kept in factored form so it would cancel. So the x minus 5s are going to cancel. So let me write my simplified expression. 1 over the square root of x plus 4 plus 3. Now I can do direct substitution on this. If I plug in 5, 5 plus 4 is 9. The square root of 9 is 3. 3 plus 3 is 6. So I get the limit is 1/6. Okay, and remember, the limit as x approached 5. If I were to graph this function, there would be a hole at x equals 5, which is why I couldn't evaluate it to begin with. Okay, b is going to be similar. You can always check. If I plug in 3, 3 minus 3 is 0. 3 minus 1 is 2. Oh, that's not correct. This must be a plus. Let me make this a plus sign. Okay, now let's try. Okay, I see the radicals of the denominator. I'm going to multiply by the conjugate. Since it's 2 minus root x plus 1, I'm going to multiply by 2 plus root x plus 1. Denominator, I just have to balance, so I'm going to multiply the numerator as well. Okay, now that I'm not going to distribute out the numerator, I'm going to leave it in factored form because I'm hoping it'll cancel later. I am going to distribute the denominator because it's the difference of squares. 2 times 2 is 4. Minus, if I do root x plus 1 times root x plus 1, I get x plus 1, but it is in parentheses, so be really careful with that. Okay, let me simplify this. Numerator's great, it's already factored, love it. Okay, now the denominator, if I distribute that, I get 4 minus x minus 1, right? Okay, which is going to be 4 minus x minus x. 4 minus 1 is 3. I'm going to take out the negative sign and then I'm going to cancel it. Take out the negative. Now I can cancel that little x minus 3 out. And then I can do direct substitution. So the negative is still there. The 2 plus root x plus 1 is still there. So then if I do direct substitution, let's see, if I plug in 3, 3 plus 1 is 4, square root of 4 is 2, 2 plus 2 is 4. So this is going to be negative 4. Okay, the next strategy is going to involve what we call complex fractions or fractions on your fractions. Okay, and we don't always object to fractions on our fractions, but in this case we do, because if I plug in -2, -2 plus 2 is 0. I get 7 over 0, which is some kind of undefined. I get undefined. I get undefined plus 1 over undefined plus 3, which is crazy talk. So I'm going to simplify this by canceling the complex fraction, and then I will evaluate it after. Okay, now there's more than one way to do that. So if you have a different method you prefer, you can do it that method. I like to do it by canceling. So if I look in the numerator, I just don't like the x plus 2. So I'm going to cancel the x plus 2 by multiplying by x plus 2. Now I'm going to look at the bottom, or the denominator. I don't like this x plus 2, so I'm going to multiply out also by x plus 2. Now, is this reasonable? It's reasonable. I'm multiplying the numerator by x plus 2 and the denominator by x plus 2, so I have not ruined the legitimacy of the fraction. Okay, now let me go ahead and distribute this. So if I do 7 over x plus 2 times x plus 2, the x plus 2's cancel. So I'm left with 7 plus. Now I'm going to do the x plus 2 times the 1. Well, that's going to be x plus 2. Okay, let me distribute the denominator now. Now if I do 5 over x plus 2 times x plus 2, the x plus 2's cancel, and I'm just left with 5. Okay, and if I do 3 times x plus 2, I get 3x plus 6. Now I'm going to just simplify this a little bit, although I could plug in right now. I just want it nicer before I plug in. So I get x plus 9 over 3x plus 11, which I can now do direct substitution on. -2 plus 9 is 7. 3 times -2, -6 plus 11 is 5. So the limit is 7/5. And remember, it only didn't exist because there was some kind of hole there. Okay, let me go ahead and look at B, and I'm going to do it similarly. Okay, I should check to see that it works, or it doesn't work. If I plug in 0, 0 over -1/4 plus 1, it's going to be 0 over 0. Even if I didn't check it, it doesn't hurt to simplify it, so sometimes it just makes it easier as well. Okay, now the denominator doesn't look that bad. It's the numerator that has all these crazy fractions. So on the denominator, I don't like the first denominator, which is the x minus 4. So I'm going to multiply by x minus 4. I also don't like the 1/4 just because why have fractions if I don't need to have fractions? So I'm going to go ahead and multiply by 4 as well. Okay, now the numerator doesn't have any fractions to cancel, but I do need to balance this fraction. So if I'm going to multiply by x minus 4 and 4 in the denominator, I have to also do it in the numerator to balance the fraction. And remember, if you have a different method, that's fine. We will get the same result at the end. Okay, so in the numerator, I have the 4x and the x minus 4. It's the denominator I was trying to make it a lot better on. Okay, so let me look at this first term. If I multiply this first term by x minus 4 and 4, the x minus 4's are going to cancel, but I'm still going to be left with a 4 plus. Now if I do 1/4 times x minus 4 times 4, these 4's will cancel, but I'll still have the 1 times x minus 4, which is x minus 4. Okay, let me simplify the denominator and then see if it got any better. Okay, the 4 plus x minus 4, the 4's cancel. I'm just left with an x at the bottom, which means I can now cancel this x out with this x out, which is great because now I don't even have a denominator. Okay, now I can do direct substitution. If I do direct substitution, that's going to be 4 times 0 minus 4, so 4 times -4, -16, which is a great answer. I'm going to go ahead and do one more just for practice. Okay, and again, it's just a complex fraction. It will be 0 over 0, which is problematic. Okay, now it's the numerator that has all the extra fractions in it. So I'm going to look up there to see what I want to cancel. Okay, so I don't like that x plus 3 squared, so I'm going to multiply by x plus 3 squared. And don't be afraid to do it because things are going to cancel in the end. That's what we're going for. Okay, I also don't like this denominator over 9, so I'm going to multiply by 9 as well. Okay, remember, if you do it to the numerator, I need to do it to the denominator, even though I don't really have any problems with the denominator. I just need to keep my fraction legal. Okay, now on the numerator, if I multiply the first term by this, the x plus 3 squareds cancel, and I'm left with a 9 minus. Okay, now for the next one, if I do this times this, the 9's cancel, and I'm left with the x plus 3 squared. Okay, in the denominator, I have a bunch of stuff. I have the 9, I have the x, and I have the x plus 3 squared. So I'm just going to make it look pretty, but I'm not really going to do anything to it. Okay, now I'm going to factor the numerator. I'm going to do it by multiplying it out, and then I'll do it another method so you can see that there's more than one way to do it, and they both give you the same result. Okay, now what I think most of you will do is distribute this out. So I'm going to have 9 minus, and then if I do x plus 3 times x plus 3, I get x squared plus 3x is 6x plus 9. And then the denominator is just going to keep staying the way it is because it's nice and factored. Okay, let me keep simplifying the numerator. So that's going to be negative x squared, negative 6x, and if I do 9 minus 9, they cancel. Denominator, still chilling. Okay, let me see. Numerator, let's take out a common factor. I can take out the negative x. Okay, and then I can now cancel out that little x, which doesn't seem like much, but it's just one factor that's normally causing the problems of everything. Over 9 times x plus 3 squared. Let me try to do direct substitution now. So I'm going to get negative 0 plus 6 is 6 over 9 times 0 plus 3 squared. So negative 6 over 9 times 9 is 81. Let me simplify that down. 3, negative 2 over 27. So I got negative 2 over 27. Okay, now I'm just going to show you algebraically what I could have also done. Where? From this step. Okay, so from this step, another way to simplify it, which is not necessarily, it's not better, it's just different. It's if you notice it. Actually, no, it's not from that step. It's from the previous step. Highlight. Right here. Okay, denominator was never a problem. So let me leave it the same. Okay, for the numerator, if you happen to notice, this is a difference of squares. This is 3 squared minus x plus 3 squared. I can rewrite it as the product of two conjugates. Okay, so since 9 is 3 times 3, I put that here. Then I have minus x plus 3 squared, which means one of these is a plus x plus 3, and one of these is a minus x plus 3. So if you notice that pattern, you could do it this way. Let me simplify it to make sure we're in fact going to get the same answer. Okay, so if I do it this way, in this first parenthesis, I have 3 plus x plus 3, which is x plus 6. In the next one, I have 3 minus x minus 3, which means I have minus x over 9x times x plus 3 squared. And then if you look at that, that's exactly the same as this step over here. So it might have saved you a step. So if you notice it, you're welcome to use it, but you're going to get the same answer either way.